Okay, so in part 2 of this unitycookie.com tutorial, we will start looking at actually writing our own shader. So let's go off and select our materials. So I'm just going to delete those unused materials. Okay, so I'm going to set these to be diffuse. Now, diffuse is the simplest shader you can use, and as you can see, it's just a nice flat shading, and it gives us a ability to input an image. So that is what we are going to go ahead and write right now. So what you want to do is create a little folder called shaders, and right click in here and click create shader. Or you can also come up here to create shader. And I'm just going to call this one here lesson 2. Okay, so we have the shader now. So what I want to do is double click on this, which will fire it up in MonoDevelop. And as I said previously, you can use a different scripting writer if you prefer. And I'm just going to delete all of that because I want to start this from scratch. So let's start writing our shader. The first thing we want to do is define what we want to call our shader, or start our shader off. So to do this, we go shader, and then we press 2 speech marks, and then we surround our shader in curly brackets, just like you would a function. So I'm going to call this one here Unity Cookie / Basic Diffuse. And just over on lesson 1, I think it was called the same thing. Nope, diffuse texture, that's fine. Just making sure that I wasn't going to interfere with anything. It's usually best to give them all a unique name, otherwise it gets confusing which one is which. Okay, so this one here is going to be put into the Unity Cookie drop down, and it's going to be called Basic Diffuse. If I save this and go back into Unity, it will probably throw an error. Okay, so it's throwing an error, but what we can do is over in our robot body, we should be able to come down to Unity Cookie, and there we go, Basic Diffuse. So if I select that, you'll notice it goes pink, and that's just telling us that there is an error with this shader. So what it's saying is no subshaders can be run on this graphics card, obviously, as we don't have any subshaders yet. So how about we go in and create a subshader. So to do this, we go subshader, and we're going to put that in curly brackets as well. So in here we're going to have a subshader. Now be aware that your spelling is very, very important in any scripting. Shader writing is no less so than any other scripting language. If you put in spelling mistakes, such as if I put in a small s, it's going to throw an error. Even though it still pops up blue, it will still throw an error. Okay, so before we go in and write our subshader, I want to come down here and write Fullback Diffuse. And what this does is it means if our shader does not work, it will render out as a diffuse. So let's save that, jump back into Unity, and you'll notice it's still pink, and there is a syntax error at line 4. There's actually a lot of errors. I will clear that. If you bring over your console, by the way, yeah, just in there is fine. it'll pop up with any errors that we have. So back in MonDevelop, you can see that it had an error here for the Fullback Diffuse because there's no shader in here. And that's really what we want to start writing. So before we write a subshader, what we need to do is define some tags. So I'm just going to write tags and then inside some curly brackets. We're just going to write this on one line. We're going to put in some speech marks and put in render type equals, and then in some more speech marks, opaque. And what this is telling us is that we want to render out our shader as an opaque shader. So we don't want any, we don't want transparency is what we're saying. So you could come in and write transparent, but what we want is opaque. Oh, there we go. Okay, so yeah, having render type equals opaque, it means opaque. So the only one we want to focus on at this stage is the render type tag. When we get into some more advanced work, we'll put in some more tags in here, but for now, all you need to know is render type is opaque or transparent, and you'll be fine. Okay, and once we've created our tags, we need to start writing our shader. Now, the shaders we're going to be writing today are written in cgprogram. So this is also referred to as CG or CG HLSL. And it is the most common shader that you'll find. There is your surface shaders are written in CG, and your vertex and fragment programs are also written in CG. The only shader that's not written in CG is the shaderlab itself. So all of this stuff around here, this is shaderlab, and what we want to do is tell the shaderlab, hey, we don't want to write in shaderlab anymore, we want to write in cgprogram. And we do that with just cgprogram, all in capitals, and it should go yellow, just to tell you that you've spelled it right. So if I spelled that wrong, say as OM instead of AM, it's going to stay as black. And to end this cgprogram, we need to use, of course, a end cg. And what that is telling the shader is, alright, we've finished programming with cgprogram, you can switch back to shaderlab now and continue on with your shader. So it'll continue on with shaderlab until it comes across the next cgprogram. And that is simply how the shader works. Nice and simple, nothing too overly complex. So let's move on. Within this CG program, we're going to start with a pragma tag. So what a pragma is effectively just some notes about your shader. So it defines some core parameters for the shader. So we're going to use pragma. So of course, we're saying, alright, on this line we're going to define some core parameters. What do we want? And we want to say surface. So, yep, what is a surface? So our surface, of course, is going to be a surf. So there's a couple of different surface types that you'll be using. A surface shader is going to be the most common, so you just need to remember surface, surf. And once we've defined what type of surface this is, we need to go in and tell it what lighting to use. So you can actually define your own lighting within the shader itself. So the shader isn't just the material properties, it's also how it reacts to light. You can fake light, you can add in lights to your model without having to have lights there. And for this we're just going to start with Lambert. And Lambert is a built-in shader in Unity. So if you navigate your way to the Unity directory, so you can see I've just gone to computer, my E drive, which is where I've installed it, program files, Unity editor, and this is all of the core resources for Unity. And we just want to go not into sand packages, we want to go into data, CG includes, and lighting.cg includes. So if I just drag that up there, You see, this is all of the built-in lighting models for Unity. So you can see here's the surface output that we're getting. So we'll see surface output a little bit later, and this is where we are referring to for this. So if you're unsure about what you can refer to, always come back here. You can see we've got albedo, normal, emission, specular, gloss, alpha, and we're going to get into what all those mean a little bit later. But what we're really looking for is Lambert. So you can see here, lighting Lambert. So that's saying we want the Lambert lighting model. And this is the actual code here. And there's also another one down here somewhere, lighting blend Phong, and that's the other one. So yes, this is very easy. So that's what we are calling when we write Lambert. And just to prove this point, what you can also do is if we take this and we just, so this isn't going to be exactly correct, but you can actually paste this in here, write Lambert 2, just give that a new name, Lambert 2 up there, and it will use this one. So we'll get into that in another tutorial for another day, but just remove that now. Okay, so when what I'm trying to convey here is when you write Lambert, it is sourcing that Lambert lighting model, as that one can be quite confusing. Okay, once we've got our Lambert, we can come down and we can write void surf, and this is a function, so we can put those in, and then we need to give this a few parameters. It requires an input and an output. So it's kind of a bit weird having it require an output, but effectively we want to tell it what it's about to output. So what variable are we outputting to? So for the in, so we have a in value. We want the input. And we're going to write it up an input in a second, but for now I just want to skip ahead to this bit. In, out, surface, output, O. Okay, so we want to take input as in, and we want to output O. So starting off with the input, what are we going to input? We don't want anything at this stage. We just want to, output a color. So let's create an input. So to do this, we create a struct. If you're not familiar with structs, it's just effectively, just think of it as a little input function. And we're going to write input. So we're sourcing input down here, so I'll write input up here. Float for color, colon, color. Now we're not actually going to use this color. What we're doing is we just have to have an input for this surface to work. So we'll get into using inputs and such a little bit later on, but for now we can basically ignore that and we'll get to it a little later. And we just need an input. So we're going to take the input as the in and we want to output O. So with that, let's write an output. O.albedo. So you can see over here, we have albedo as a fixed 3, so it's expecting a RGB equals 1. So 1 is not an RGB, of course, but it can interpret it. Effectively 1 is white. So if we save this, we jump back into Unity, and it's given us a bit of an error, which means, as you can see, we have a syntax error on line 10. So we'd come in here and would see that there is a syntax error just here. So I'm guessing that I don't have a... Nope. Oh, output. Here we go. So I've forgotten a T, I spelt that wrong. So you come across this a lot, and I'm going to leave a lot of these errors in this tutorial as I make them, because you're going to run across them absolute ton when shader writing. There is a lot of errors, and for me to leave them in the tutorial will certainly help you learn how to come across them. So that one there, spelling mistake, find it, fix it, and you can move on. Alright, so there's another error, syntax error at line 10. So same one. So just going through this, we have up here, we've forgotten semicolon. So it's another one that is going to catch you off guard sometimes, is you'll forget semicolons. So if you put that little semicolon here, I can see there's no more errors, and we can save that, come back into Unity, which will load up in a sec, there we go, and it is white, so it's a plain diffuse white shader. Okay, so over here, just going through this again to make sure that you guys understand it. We have our shader, we've named this via category and name. Within our shader, we have a sub-shader, and sub-shaders are the actual shaders of our shader, and we can use multiple ones of these. So we have our sub-shader, of course, and within that we have our tags. So this line here, we want to tell Unity that this shader is an opaque shader. We're telling it don't expect transparency, just render it out opaque. And after that we use these cgprogram codes to tell it we're about to start using this cgprogram language. So stop processing shaderlab, start processing cgprogram. We have our pragma, which is our core properties of our shader. So we have pragma, and then our surface type is a surface. So it's not a vertex or fragment program, it's a surface. And we're using the Lambert lighting model, as we have defined in our lighting.cgincludes. There it is. Next, we have a input struct. Our input struct is processing any inputs that are not our own inputs. These are inputs sourced from the code itself, so UV coordinates, vertex colors, those kind of things will pop up in here, and we're going to get into that in a later tutorial, but for now just accept this as a input. Then we have a void surf, so we are writing our surface here. We're going to use our input as the in value, which means we can take these values and use them in here. And we're going to use our in-out surface output as O. So anything that we assign O to. So we have albedo, we're assigning 1 to O.albedo. So it's going to take that O and it's going to place it into our output. And of course, yes, O.albedo is color. And after that, we simply close off a couple of tags. So finishing off what we've done up there. So we've gone back to shaderlab syntax after that NCG. Then we jump to a fullback diffuse. And a fullback diffuse just means if the shader couldn't run any of those sub-shaders, it's going to use diffuse, which is nice and simple and stops any major errors in our shaders. And that there gives us this one. So of course you can come in with the shader now and you can adjust this color. You can maybe put in brackets and go 1, 0, 0. And this will not work. Well, it shouldn't work. Oh, there you go. See, it's just gone black rather than anything else, and that's because we haven't actually defined a color here. So we're going to get into how to change our albedo color later using images. We'll use sliders, image sliders, and all that kind of stuff. But for now, we'll leave it at 1 or perhaps 0.5 if you want to make it a half. There you go, so it's 50% grey now. And just have a play with that, see what you can come up with. And yes, that is our first shader written. So hopefully all of this mumbo jumbo of code is starting to make a lot more sense. You can now create your own materials, you can assign those shaders and place them on whatever you want. So in your file you might have a sphere, and you can create a sphere, put your shader on that. This one here, I've just put them onto a robot. So we can, just to prove that, we can create a other game object. Just going to create a sphere, and on the sphere we need to assign a material. So we can create material, and I'm just going to call that new material for now. Throw it in the materials folder. We're going to give this one here Unity cookie basic diffuse, and let's just drag that onto the sphere, and this sphere is now using that material. Okay, so that's it for this lesson. Let's stay tuned for the next one, and we will be looking at working with properties.